Welcome to Onsite with TED. I'm TED. This podcast was originally an internal training tool designed to create a better understanding of today's industry as it constantly evolves. We appreciate you watching. Please remember to like, subscribe, and share.
I'll defy the night. I thought I knew what was right. Every time I tried to justify. What was it you did wrong? Stare at me and wonder what it is you've done wrong. I'll build you up to tear you down, and I'll do it again.
Welcome to Onsite. We're here with Billy Gallagher and Reese Jones with K-BOS today. How you guys doing?
Good. How are you?
All right.
Doing excellent.
Today's episode is brought to you by Keller Williams Northeast Homegirls. Give them a call if you're looking to move or sell your home. So, you guys want to get started?
Yeah, let's do it.
All right. So, how'd this come about? Like, how did we go from the old standard hydraulic, you got to have X amount of pressure and this amount of fluid to wham, done right now?
Yeah, it's a good question. It sort of starts with two friends, one being my brother and the other co-founder Steve in Korea on a beach, pontificating on how can we do hydraulic, how are we going to do shear rams better because they were failing in factory acceptance testing in Korea, and basically from there the spark went that we need to hit it with kinetic energy, right? And that's just that's how the military does it. That's my background. That's my brother's background, the former CEO of the company. And from there, what started off as a paper idea led to raising capital, led to prototyping and commercialization.
All right. Right. You want to show one of these things?
Let's do it.
Well, so we want to get off on the right foot, right?
Fair
So
enough.
let's first talk about the problem, right?
Right.
So we're here to stop blowouts. Okay. So let's all agree that if a blowout happens, a lot of bad things and also many stupid things happened.
Yeah.
Right. But the last bad thing that happened was your blind shear ram didn't work. Right. That's the last thing that if you had a blind shear ram, which some would argue you should. Yeah. So if you had one and you tried to use it and it didn't work, that's a blowout. Right. So can we put a picture up of a tubular? So blind shear rams don't work when there is a unshearable across the BOP, because they're only rated to shear certain things that you run in whole, right? So if you have an unshearable across it and you need it, you're in a world of hurt, right?
Yeah.
So on the screen, we're showing you a 9.5 inch, 214-pound tubular. This is a big BHA. This is the biggest thing you would ever run across a BOP while you're constructing a well in the oil and gas.
So you're about to cut a 9.5 inch collar.
Well, yeah, let's put up the next picture.
This is what it looks like after a K-BOS has been activated through it.
Yeah.
Now that's impressive.
Yeah. So we've been having a really good week. Billy's riding cloud nine right now. So we just are going through the final steps of the qualification program of our 18 3/4 inch, 15,000 PSI K-BOS, and it can shear and seal on a 9.5 inch BHA. And here's the picture.
And I don't need an accumulator.
That's right. That's right. No accumulation required.
Nice. So if anything goes wrong, if you were equipped with this, it would literally stop all blowouts.
Well, let's
excluding underground, of course.
So I don't want to let's just talk. That is, I think, a fairly accurate statement. We're making some assumptions. The BOP is correctly nippled up, right?
Right.
The K-BOS is available and installed, right? So you have to. There's things you have to do, and you have to understand. We're not saying it's not going to fail, but you'll know if it has failed, right? And that's a really important thing that I would want this audience to understand. Is really, how it works, how you operate it. The K-BOS is not a hydraulic system, right? So the reason why we test our well control equipment is so that we know that it's available, right? When you're testing, you're looking to detect failure modes, right? So it's all about being able to detect failure modes and what's the best way to do that without interrupting your operations, right? So the K-BOS has different failure modes from a hydraulic BOP, and therefore the testing for those failure modes is different.
All right. So that was one of my questions that was coming up. I know how I test, let's say a pipe ram.
Yep.
I close it. Once I use this, it's a one shot, and then you got to recharge it, right? So how do you test these? How do you prove that test for your governing body or the regulatory body that happens to be over that area?
Yeah. So got it.
Yeah, I was just gonna say in the shortest way, like, so one of the great things about the K-BOS is it's an electric based control system, electronic based control system. So it is monitoring all of its major failure modes continuously. So you can sort of think of it as it's continuously testing to check that I'm ready to fire. There's no reason why, if an operator needs it, that it won't work. Right. We can go through some of the, advanced studies we've done with other people, but like, in the shortest sense, that's how it's tested once it's on site. It's always checking. So instead of having a 7-day interval, 14-day interval, it's, literally continuously monitoring the system ready to go. So that's from, how does that work? And then to the next question where that leads is, like, how does a regulatory body accept that? I might let Reese take that one.
Yeah. So in this industry, sometimes we're arguing with the regulator about, hey, what you're asking me to do is too hard or unnecessary. I want to do less.
Right.
Right. Well, in the case of the K-BOS, we are doing something different. So it requires, we have to talk to the regulator, but we're asking the regulator permission to do something safer than what's required.
So it's more stringent than their regulations.
Well, that it exceeds the requirements. Yeah. So that's a different conversation. And when you get them to understand, yes, we have to do things a little bit differently, but the result is going to be significantly safer than what we would do normally. That they're supportive. They're very accommodating. How can we get to yes? And what's the documentation that you have available, and how have you done it? So if you look at if you wanted to have a bunch of references, right? So if you can lean on a standard in this industry, you are much better off, right? Okay. So what we did is we said, all right, let's pick a standard that we're going to follow. And we picked API 16A. Right. Okay. So that's a standard for blowout preventers, right? And it's a very good guide to follow. However, there's a lot of requirements in that standard that are specific to hydraulics, right? So we go through and we say, all right, how are we going to meet the intent of all those things, right? And then we do we follow a process called DNVGL RPA 203, which is a qualification of new technologies. And that allows you to qualify your device to the intent of a standard that closely matches what you want to achieve. And that's how we get up in front of the regulators, and we get DNV or a third party to come and say, this is certified to DNVGL OS E101 with reference to API 16A as qualified by the program that we agreed on, which is per the process. So that's the shortest way to answer that question.
I see a lot of the DNV guys they know for sure what they're doing.
Yeah.
So, like follow-up questions to that, you said that it's continuously monitored,
right?
And I'm making an assumption,
right?
Like I've seen the videos, I've just never actually put my hands on one. I'm assuming that's kind of like an umbilical cord or something, like a muck system, and you've got a PLC that's reading it.
Yeah, it's basically exactly how it works, and in a little bit more detail, how the heart of the K-BOS is two space standard initiators. And so to fire it, you just need to get an electrical signal to it. And what the control system's doing is constantly checking that the line is available. And then it also has like a test fire circuit that goes through and periodically test fires it to a standard to claim a continuous monitoring standard.
Okay. That just answered my second question, like, because you got to function test them every so often.
Exactly right.
Okay. So my understanding of it, and the way that I'm not trying to dumb it down or make light of it. I think this is one of the coolest things that's out there, and I think it's going to take over as a standard, hopefully, because this benefits greatly outweigh the cost, right? But at the most simple version that I can think of is it's a Hilti gun, but it's on your RAM,
Mm.
right? It's bam, done right now, over instant transfer of energy.
Like a pyrotechnically actuated nail gun. Is that what that is?
Yeah, yeah.
There you go.
Sorry, I used a brand name.
yeah.
Yeah.
I'm being sponsored.
Well, that's a great question or great comment, right? Because one of the concerns people have is, hey guys, running perf guns is a pain in the ass, right? We have to have a magazine and we have to have special permits and all this stuff. Well, like you for a Hilti gun, you don't need any special permits to do that.
Yeah,
Right.
it's just 22 show.
Yeah, airbags in your car also. You don't have to get a special permit to bring your car into the parking lot. And there's a bunch of gas generators in your car,
I have been hit by an airbag, and that's not good.
but you didn't need a special permit to get hit.
No,
No.
but I remember it. I sit obscenely close to the steering wheel, believe it or not.
But so there's existing regulations in every country that we've dealt with so far. And we just say the K-BOS works like those things. And the government says, yep, okay, cool. So it is not regulated as an explosive at all.
Nice.
It is not. It's a tool.
That's perfect.
Isn't that great? So it makes it easy and it reminds all of us that it's very safe to deal with.
No, one of the questions I can visualize this on land. I can visualize this, like in a wireline situation or coil tubing or snubbing, because like those guys they're not working well control. They were doing pressure control, right? So I can visualize it there. But what about like these deep water installations, like on production platforms or even a new drill? Like, because you could be 8,000 to 12,000 feet away from that wellhead. So how does it integrate into a drill ship, or how does it integrate into a production platform?
Right. It's an excellent question. So believe it or not, our first commercial deployment was on a deep water drilling rig in the Gulf of Mexico. And the first job that KBOS did was in, what was it, 10,000 foot of water thereabouts?
Yeah.
Yeah. So the first model we came up with is designed to retrofit into existing BOP stacks. Principally because they're massive. It's not an easy thing to just go and add something. But what we did, which I think is quite innovative, is it doesn't matter which BOP stack you've got, we can retrofit into it and provide you a K-BOS. And that's really for the subsea market specifically. And then on production platforms, as it would have been our second or third job, a similar thing as a drilling and production platform, and they had some casing that they couldn't shear, and we added on to that, integrated into the existing stack.
So this really does open up a lot of opportunities comparatively to your standardized, stack that we've had for decades.
Yeah. To complement Billy's answer, I'd say just help everyone understand the control system is electronic and it's completely independent of fundamentally independent of the hydraulic control system.
Right. I think that's an important point to.
Yeah. So you can integrate it in any way you want or run it completely independent. And that there's pros and cons of doing it that way.
So it doesn't have to be part of the EDS.
It doesn't have to be, but it's very easy to do that, right? So we replaced the casing shear ram in the specific case of the Invictus, right? And so you still had that control system for the casing shear ram in place. So we attached a pressure sensor to receive that signal, that hydraulic signal that then tells the electronic control system, I want to close the casing shear ram. And then K-BOS says, okay, and does its job.
Nice.
Right. So it was a very elegant way of integrating into that system.
So this is a curiosity question. I'm going to have this written down in my script. Before, when you use shear rams, you have to have some kind of string weight there, right? Like there's got to be some kind of tension. If I were to hold a rag up and try to cut it with a pair of scissors, I'm not really doing much. But if I hold that tight and somebody else cut it, that's a different story, right? This seems like it might have enough power where I could be literally set on bottom after dropping the blocks and lean into the side, and it would still just done.
What if you threw a rag in the air and cut it with a katana?
Then I'd be a ninja.
That's K-BOS.
That's K-BOS. Very good setup there. Nice.
Can I change my answer to Jedi instead?
Oh yeah,
Sure.
All right.
but with a katana, not a lightsaber.
Yeah,
I'm not.
no, it's more like a katana. No, technically incorrect.
Well, the black saber, right?
Okay.
The one from the Mandalorian. Yeah. All right. What else are you guys working on right now? Like, what else are you? Is there something that you're building that, like, this is the base of it, right?
Yeah.
So in 1969, Chevrolet had a Camaro, and we got a bunch of other stuff from that. So like, is there anything, is there add-ons? Is there something to make it even cooler? Or
That is
Right.
such a fun question.
I don't know. You look. Yeah.
you're
Right.
smiling? big.
He's so happy.
Oh, man.
He's so happy about you. You asked him that.
Oh man, yeah. So let's reel it in, right? Because there's a long-term view where we change the entire pressure control mechanism methodology, right?
Right.
We're controlling pressure, annual pressure, emergency shut off. We have a vision to really do this in a much more reliable and cost efficient and lightweight manner. So there's a lot of benefit to that, right? Long term. But let's back that up and say, what are we doing right now? Right.
Mhm.
So two things. One is we're working with ConocoPhillips right now on a control system. So when we built the K-BOS and it has electronic control system, we realized, hey, we've got a really good control system here. What else can we control with it? Right.
Yeah.
And so we're working with, like I said, with ConocoPhillips, and came up with an electronic based electronic energy storage alternative to a BOP closing unit. Right. So let's compare it to a jackup rig, for example. You got 88 bottles. You've got 2 big pumps. You've got a huge area for all that set on your cantilever and taking up a bunch of space. And you have to go check your pre-charge to know if you have any pressure or not. Right.
Right.
So our what we call the remote valve manifold, stack light remote valve manifold system is about the size of a closet. Or
This is why we use
refrigerator.
acronyms, right?
RVM.
It's so much
Yeah.
easier to just say RVM.
Yeah. So the stack light RVM is takes about the same space as a refrigerator to do that same job.
No way.
You got it.
That's cool.
And if it fails, it'll tell you right away.
And is there a redundancy? I mean, it's offshore, like there has to be redundant, right? So is
It-
there a
yes.
redundancy in case this package fails, that you got another one?
Yeah, and that's a conversation, right? Where we can decide how much redundancy you want and how much is required to meet your requirements, right? So that's a conversation, that's a configuration question, but yes, there is.
All right. And we got a handy manny chat from question. What do you got?
Yes, we got a question from the group. How do we open the well back up after the shear?
Okay, with the K-BOS?
I believe so, yes.
Yeah, so the K-BOS closes pyrotechnically and then locks and seals. And then when you're ready to open it back up, you engage with it, you open up the locks hydraulically and pump it open hydraulically. It's very
Very similar to a normal hydraulic BOP at that point after it's done its core business.
that's right. So when you're ready, you can open it back up.
All right. Now, so there's some BOPs, especially subsea ones, that, you know, that need that hydrostatic assist port because water depth and everything's trying to push on it and how did you combat just the hydrostatic head of the seawater, much less having, you know, 8 to 12,000 feet of drilling mud on the inside of the riser?
So the K-BOS is unique. So to create the kinetic energy that we're using, which is just more efficient than the hydraulic energy, for example, right? We have to accelerate our working components. So you can't accelerate something if you are displacing an incompressible fluid like water or wellbore fluid, right? So we have to isolate our working components from the wellbore at all times until you activate this thing. So if you think of K-BOS, it's really just a spool that's sealed and welded up, and that's it. And all the working components are in a hermetically sealed chamber behind the scenes until you set it in motion. And so if you wanted to just think about it that way, we've got a casing around that has an 18 3/4 inch drift, right? And we're going to shear that first. Then we're going to shear the BHA in the well. And then we're going to put a gate across the well bore, and we're going to seal on the top and bottom of that. So because you're pressure balanced, you're not affected by hydrostatic pressure at all.
Nice. All right. That makes a lot more sense.
There you go.
All right. So I know this is going to become more prevalent in the industry as time goes on, and I think it's going to happen sooner rather than later. So for not just well control wise, but training wise, what is the one thing, maybe not the most often question that gets asked to you, but what is the one thing that you really wish people were to know about this? I mean, like if you could tell somebody one thing about this, what would it be?
Thankfully, we've covered most of those points already. From a training standpoint, you want people to know what it's not, right? It's not an explosive, right? It's not a special permit tool that you have to work with. It works just like a BOP. How do you prove that it's available, right? And then what can it do, right? So I'd say beyond what we've already talked about, we've worked a lot with the industry to understand what this means, right? And one way to look at it is in terms of the relative probability of a blowout for a given well with and without the K-BOS. And man, that's a really boring thing to explain, but the result is exciting, right? So we did this particular study on a well with North Caspian Operating Company in Kazakhstan and ENI, and Qantas did the work, and it showed an order of magnitude reduction in the probability of a blowout with K-BOS relative to what they were going to run standard. That is a big deal.
Yeah.
Now, just to add on to that, like, the question to what would you want to say to an operator or someone that's using the equipment, it's there when something goes really wrong and nothing else is working. From our point of view, it's designed to be your last line of defense, right? Like if you're having a bad day, a really bad day, you hit that button, you have to enable it to start with, and then you press fire. So it's a 2-button switch to fire it. This thing will close in the well in less than a second. And so for most of its life, it's just monitoring itself, and there's not much maintenance really at all besides what you have to do from a regulatory perspective for pressure testing. It's just a very simple, low maintenance device designed to work like an airbag.
All right. Now, I'm assuming it's going to be the way that you rig it up. So let's say I replace or I put double gates for my lower pipe rams and I have this below it. Is there a pressure gauge on that can read the pressure beneath it, or would I have to come up through my casing valve? If I do have to shear this and I'm below my mud cross, how do I read pressure?
K-BOS has a side outlet. Yeah, so you can rig it up with a blind or rig it up with a pressure sensor on that blind. It's really it's not important to K-BOS how you detect annular pressure below it.
All right.
Yeah.
Okay, there's a question from Handy Manny from the chat. What do we got?
The group says, how long does it take to complete an EDS sequence or semi or drill ship?
Yeah. All right. So we're talking about DP operability. Yeah. We're talking about emergency disconnect sequence. Yeah. All right.
Yeah,
cool.
This is probably after you're hung off, right?
Well, you don't. So you could hang off if you want, but that's fast. That takes time, right?
That's right.
And you have to know where your tool joint is. So let's get to this real bad day, right?
Right.
You're pushing a button, you leaving.
That's right. So with a K-BOS, you don't have to care about hanging off. You don't have to worry about any of that. You're saying, I want off this well, right? So you fire your K-BOS, and in a period of milliseconds later, you've secured your well. And you can do that with an exceptional high level of confidence that you are going to shear and you're going to seal. So based on that level of confidence that you did not previously have, you can look at optimizing your EDS sequence and say, do I really have to do it in that order? Can I do this faster? And we've shown with a lot of studies working with Kongsberg Marine and working with Wood and working with Transocean and Ventura and Petrobras and some of the other drilling contractors out there that you can accelerate this EDS to, in some cases, as fast as 9 seconds.
Wow.
Yeah. So it really, you look at your LMRP unlatch function, you say, how fast can I do that? And that's your time. So some rigs, it's 20 seconds, some rigs, it's 23 seconds. Depends on those LMRP connectors have different configurations, right?
Right.
Yeah. So as soon as you hit EDS, you start that unlatch function, and when it comes off, you're off. Right. So that has a huge impact on your watch circles, because the amount of time that you have until you get to that point of disconnect is increased, right? So if you think about your emergency systems that would recover a rig from blackout, they're designed to work in 10 seconds. And then it didn't work. Do it again. It didn't work. Get the engineer down there and figure out what happened. So what if you, instead of having 60 seconds, what if you had 140 seconds to figure it out? You can probably avoid a disconnect, which everybody here knows that's a pull. That's 2 weeks. That's a lot of work. That's recovered.
You hope it happens at night, so there's not a
Yeah.
sheen.
Oh, right. It's going to be a long couple weeks and very expensive. So not only do we think we can avoid most EDS scenarios, we think we can avoid being in the yellow watch circle. So you're increasing your drilling time. And then you can look at when you're drilling in shallow water or in hazardous environments like in the North Sea, where the norm is moored vessels, and you could say, I think we can enable dynamic positioned operations in this environment or on that well. And if you can do that, you save all that money and all that time and all that fuel and all that carbon emissions. So there's a very compelling value case if you look at DP operability.
Nice. I did have a curiosity question for you.
Right.
You and your brother, and obviously explosives in the military, stuff like that. How did you think of this? What was the epiphany? Were you drinking beer playing golf, or
Yeah, that's probably a good one for Steve, though. I think like Reese was saying before, is like there was a known industry problem on unshearables, and it's just a spark on, well, if I hit it with kinetic energy, that's the best way. That's how the military does it, right? Like since the dawn of the military, that's how they penetrate armor or any type of metal. And then from there, the idea built, and I sort of came into it as the one that had the real background in pyrotechnics and explosives, and that was my specialty in the Australian Army, and we built the company from there.
Yeah,
Nice.
think about it, right? You don't hit a tank with a pair of scissors,
Right.
right? You hit a tank with a kinetic energy round,
Yeah.
and it goes in there and it does its job. So why are we hitting a big drill pipe with a pair of scissors?
That's a very good point.
Yeah, so stop doing it. Use a KBOS.
All
Hit it
right.
hard and fast.
We got another question from the chat out of Handy Manny. What do you got, buddy?
The group wants to know, is the K-BOS able to seal and withstand pipe being ejected if the well is pipe light?
That's a good
Absolutely.
question.
So this is one of the fun things that we did. We did this to come up with all this new technology on being able to shear anything. We developed this really advanced finite element analysis model. So it's a bit of like nerd speak, but long and short of it, what we did was we modeled it moving at 10 meters per second, 20 meters per second, 30 meters, just ramp up the speed and just turn the K-BOS on in the model and watch it shear. And, the K-BOS is moving so fast relative to that pipe, and the structural integrity of the gate just allows it to just handle it. It just absorbs it like it's nothing.
That's nice.
So yeah, you got a pipe like this coming out, it's shooting out. It's another place of like, man, that's a bad day. Hit the K-BOS. Okay,
Make it stop.
make it stop. That,
Nice.
I pride myself in us being able to do that.
Well, at one point in time, like acoustics were a big thing on the rigs,
Right.
right? And then the law got changed to something to the effect of, if you have acoustics, they must work. And then like everybody's like, well, we'll just get rid of them. So now there's no more acoustics. That we still have remote capabilities though, right? So does it come with a remote capability, or is?
Yeah, absolutely. So you can be intervene with an RV panel if for some reason the mux cable or something got cut off, or some other weird disaster happened. It's got a battery that's sitting down there ready to fire the device, and you can do it through acoustics. We've done some options there, or the other standard way is using the RV panel. Just pump in pressure into the RV panel. It sets off the PTs that will fire the device.
Okay.
Yeah,
All right.
to summarize, it's an electronic control system, right? And we can receive analog or digital inputs.
Right.
You tell us how you want to tell it what to do, and we can make it work like that. So it's that simple, which is good news.
Right. Now with as popular as I believe this is going to become, or even required in some cases, or a lot of cases, is this, I know you guys hold a patent on it, but is this a rental tool? Is this something that if I'm building a brand new rig, I could just make it part of that package, or is it both? How do you do this?
We're open for business. Yeah, so we have rental tools and we sell K-BOSes, and that's it.
We got another question out of the chat from Handy Manny.
Yes, the group asked, what is the potential for US land-based operations?
The potential for US land-based operations. Well, I tell you, K-BOS is an excellent rental item in the case where you don't always use a blind shear ram in US land, right? So sometimes you need one, and so you go and look for renting one. And when you rent one, well, then you need a whole bunch of accumulators to close it. And maybe you need to worry about the volume requirements of that accumulator system and rigging it up and all the other stuff. And you have to check it, and there's maintenance involved. And anyway, K-BOS is a very economic and elegant alternative to doing that. So if you don't need a blind shear ram, you don't need a K-BOS. But if you do need a blind shear ram, K-BOS is probably a better option. And we have a couple of units working right now that apples to apples scope all in was less expensive. So
And less of the logistics headache as well, because you don't have all the accumulator bottles.
that's right, Billy. Yeah. So tell me why you're not using one.
So curiosity question. I can see a 9.5 inch collar, right? I can see it being sheared. I'm okay with that.
Mhm.
Slick line. There's not a lot of weight there. There's not a lot to absorb that initial brunt. So, and it's going to be smaller, obviously, right? So
Right.
have you tested it on slick line or braided line even, and has it just shoved it over to the side and like caught it? Or, I mean, does it just whack it right now like a pair of scissors through hair?
Katana.
It's like a katana, basically.
Okay.
We've done lots of cutting of wire line, slick line, braided cable, you name it. You put anything in there. I wish we had a YouTube channel. It'd be pretty exciting. But basically, yes, it'll cut all those. And again, it's got to do the speed of the cut. So if it's not torn or anything like that, it doesn't matter. And that's all been part of our existing qualifications.
Yeah, on a lighter tubular shear test that's required, sometimes they'll just go and tape some slick line or wire line on the side of the bore and just let it cut it.
Yeah.
All right. Oh, we got another question from Handy Manny.
We have a couple actually. The group wants to know, what is the size of the K-BOS? Is it smaller, larger, or the same size as a normal ram? And then second question, what is the largest and heaviest pipe you can currently shear?
All right, so for size and weight, I think I can give you a brochure, but if you just think in your mind that it's basically the same size and weight as a dual tandem blind shear ram, then
that's about it. Yeah, that's about it where it's comparable. Dual
tandem. Yeah. So then what's the limit, Billy?
Well, I guess from a technology perspective, we've done a lot of modeling and everything right up to tubing hangers that it could potentially shear. We haven't validated that in testing because someone have to donate one to us. But there hasn't been anything that someone submitted to us that we can't shear.
That's right.
Effectively. So there is no casing that you'd run through an 18.75 inch BOP that I'm aware of that we don't cut with a multiple factor of safety. If you imagine, the whole thing's designed to effectively shear drill collars, and that's a lot of heavy, dense, strong metal. Everything else is easy compared to that for the K-BOS.
Yeah. Specific examples: 3.5 inch drill collar and a 5 1/8 inch size
Right.
K-BOS, a 6 3/4 inch drill collar in a 13 5/8 BOP. Right. So a 13 inch casing or 12 3/4 inch casing, anything you would run through a 13 inch BOP, we can shear. Right. So we're pretty excited about all that. Yes,
All right.
sir.
I was just wondering, do y'all have any videos of the K-BOS working?
So there's a real good one on LinkedIn.
Really?
Yeah. Go check our LinkedIn, and it's a post from Transocean. And it's a video where they're talking about the first shear test subsea on the Invictus in the Gulf. And it'll show a video of a shear test in our yard with some good audio. And then it'll show the shear test on the ocean floor.
Okay. Okay. And a question. What kind of locks does it have post closure?
Sorry, repeat the question.
So like you got U-Lux, T-Lux, Super Lux that, you know, you got to have.
Oh yeah,
So
I gotcha.
it's required that it locks in that position after it fires. So
Right. So the K-BOS has you know, a pretty unique lock. So it's, you know, a kinetic lock, I guess, for lack of a better word. And it's activated with the residual. It's like an automatic weapon, right? Like you fire, it goes past a set point and the locks come out. And for us, it's a slightly different in the sense that stops positive reopening of it, right? And when we seal, we seal top and bottom on each of the K-BOSes. So you don't have any differential pressure trying to unlock the system. I don't know if you want to expand on that, Reese.
Yeah. So on a traditional blind shear ram, you're pressure assist, right? So you have your rams together and the wellbore pressure below you is holding those rams closed. And if you lose that wellbore pressure, or if it goes negative, those rams could come apart.
Right.
And so you have a lock there to mechanically hold everything closed, right? K-BOS is different. You've got a gate across your wellbore, right? And so there's no reopening force. If we're sealing on the bottom of that gate, there's no reopening force, right? So the locking problem for us is a different challenge, right? So if that bottom seal fails, then we're going to float. Sorry. Then, yeah. If the bottom seal fails, then you're going to flow around that seal and you're going to have pressure on the gate and push that gate back
onto the locks.
Onto the locks. And the locks prevent that gate from backing off from the wellbore so that the top seal remains engaged.
it's a big ass zip tie.
It is.
Okay.
Yeah. Is that right? That's right.
Yeah.
The locks are half moon dogs that engage around the piston and keep the gate from pulling back.
Okay. I like it. Simple, easy, make it work.
Yeah. And we'll give you a slide deck that shows you all this.
Yeah.
Yeah. We can put it in the training manual.
Well, I'm a firm believer in the less moving parts, the less likely it is to break.
Yep.
So
That's right.
okay, we got you some easy questions. I want to ask you the hard one now. Your green carbon footprint, the ESG score. How is this going to help me with that?
So you're not going to have a catastrophic blowout that would make the ocean dirty and the beach covered in tar, and you won't be cleaning oil out of bird feathers, right? So
to be fair, that bird was going to end up in oil when I cooked it and ate it anyway.
Well, it's different. That's a different life choice.
Hey, nobody loves the oil industry more than me. And so I really want to protect it. And the best way to protect this industry is to prevent those black eyes from happening.
That's right.
Right. And so this device dramatically reduces the likelihood of a catastrophe like that nobody wants. Yeah. So that's the biggest way.
There. And that was you guys know the incident that we're talking about, but that was the biggest thing that bothered me about the whole thing is it was all about the environment and not the people. Right. We didn't just lose environment, we lost people.
That's true. Yeah.
Right. I became a trainer from the field because I wanted to make that difference, right? Where I may talk to 500 people and only one of them listens, and maybe I got something through to them that might help them one day, right? This is going to make that difference.
That's what we believe. That's why we do what we do.
Yeah. So, and don't get me wrong, I mean, the environment is very important.
Well, you just asked me about the environment.
That's right.
Yeah.
But it's
But
right.
it's
It's about people as well, right? It's safety enhancement onto whatever rig that it's on.
My favorite thing about the K-BOS is these romantic pictures of this giant plume of fire and this guy covered in tinfoil walking up to it to try to turn off that well. That guy doesn't have to do that anymore. He just push a button and it's done.
That's nice. Now, what if things got out of hand too fast? Like, not say somebody wasn't paying attention and computers go down.
You have to change your logo.
Yeah. Well, I wanted to redesign the flame anyway.
Yeah.
I'll make it smaller, make the derrick look bigger. But let's say things did get out of hand.
Yep.
Right. And they did have to bail. Everybody's in lifeboats. How would they still be able to fire this off to stop it so we're not flowing into the ocean for weeks and months at a
Right.
time?
So this is all up to how you want to run your facility, right? So every customer we talk to has a different philosophy on this.
Mhm.
Some customers are like, okay, I know my people, we're going to run, right? So let's put a control panel for the K-BOS where the people are going to run to. And that's what we did, right? So it's just an electrical cable. How long do you want it to be? 600 feet long. Okay, we'll run it over there. We'll set it. And when you're done running, you push the button and it stops, right? So on a platform, we have a design that rigs up next to the lifeboats. So as you're getting in the lifeboat, you shut it in. But other customers say, we're not going to run, we're going to fight. So they have it right there at the driller's panel in the tool pusher's office and in the other office. And they're like, we're going to
stay.
We're going to stay. We're going to
and close it in.
Yeah.
Right.
So what's your culture?
Mhm.
And put the safety button where you want it.
So you got the guys on the Titanic still playing the piano and stuff, right?
That's
How
right.
we're staying.
Yeah.
Now, with things that are coming out and this like API, right? Or NORSOC or whatever, there's regulations and there's recommended practices, and then there's actual standards and regulations, right? So what is going to have to be changed, or is there any workings with this going forward with API, NORSOC, whoever, Bessie maybe?
Man, yeah.
Right. Like, I guess we're working on every front that you just explained, both with API and the various committees for 16A and standard 53. Maybe Reese can talk a little bit more with on those other points that you touched.
Yeah. So we're in 5-year-long conversations with Bessie, with the Petroleum Safety Authority in Norway, with the SOS rep and the UKHSE, with NOPSEMA. We have good regulatory relationships in Brazil with ANP and everywhere we go, so
Yeah, it's a conversation that we're having. It's new technology. People like it, and they're trying to figure out, how do we adopt this into the industry, because it is, it's different. And so,
I lost my train of thought. What needs to change was a question, right? So
so like the acceptance is already there. Once acceptance happens, regulations start coming out.
Yeah, we're asking regulator to do something different that's better than the way they do it today, right? So one change that I think a lot of people agree on is, instead of having standards and regulations that talk about hydraulic equipment, we want functional requirements that talk about
performance requirements.
You shall secure the well in this much time, and you shall be able to cut these things under these conditions.
Oh, you're using that shall word now.
Well, you said regulations, right?
That's what happens with the regulations, right?
Yeah. But see, that's different than you shall have a hydraulically actuated thing with 22 bottles that can close at the calculated pressure of this depth, which is very specific to one technology, right? So the direction that I think the world is headed, which is the right direction for us and for everyone, what you want is innovation. If somebody comes up with a better idea than K-BOS, well, I hope they use it, right? And so you want to enable innovation, and that's the right way to do it.
All right. This question didn't hit me till later, and you were talking about that still on the electronic monitoring, right?
Right.
And how it updates itself every few seconds. Is there a recorder that goes with that? I mean, like, is there something that says, yes, it has been tested at this point in time to this amount or whatever?
Yeah, absolutely. And that's a requirement of 16D to have a histogram in there. So the PLC based control systems have that. And then we have some other ones that are like printed circuit board, which is a little bit, it's a constant state machine. If that makes sense. Like, it's just constantly, it's either yes or no.
Okay, so let's say I'm on a deep water drill ship and I'm the company representative, and I'm supposed to sign the ticket that says, yes, I witnessed this being tested to X amount of pressure for this long, right? how do I recognize, or how do I feel comfortable signing that same document or getting that same paperwork in for the KBOS?
Right. Well, if they're witnessing a pressure test, it's no different to how you'd witness a pressure test on a normal BOP. And then a lot of the condition monitoring is agreed up front as a part of the approval, and that's then accepted by the regulator in a part of the submissions for like APDs, for example.
Yeah. The key thing for using KBOS safely is training, right? So, for example, when we're running on a coil tubing site, you have safety meetings at 6 and 6, right? And so at the safety meeting, you explain, hey, there's a new piece of kit out here. The biggest risk of running this kit is an untrained person uses it and inadvertently activates it. So no untrained people can touch this thing. Don't touch it. Who's trained here to use it? Well, I'm the person trained, or the person who's giving the briefing is the trained person. And you say, all right, then, and you explain a little bit about it and get a little sales pitch and talk about, hey, if things go real bad, we're going to shut this well in and everybody's going to be safe. It's great news for all of us, right? So that's part of the training.
Right. And now, earlier you said that it's still a two-handed function, right? So what that does is, like, the right side of your brain controls the left side of your body, left side of your brain controls the right side of your body. That makes it a conscious decision.
Yep.
Exactly. So is that's to take that human error away?
You do not want to be able to accidentally do this.
Right.
Well,
you don't.
That's done.
That's another story for another day, I guess. What you got, Manny?
So we got a couple questions from the group. Firstly, what kind of pressures can it handle? I'm sorry. What kind of temperatures can it handle?
All right.
I'll let you answer, and then I'll ask the second one.
So KBOS is nominally qualified to 250 F. We have some designs that are qualified to 350 F. The design itself is really interesting because we protect a lot of our seals from temperature. And so it's uniquely suitable for high pressure, high temperature applications. And it makes those qualification journeys technically less challenging for the equipment. So we haven't done it yet, but we're open to the challenge.
All right.
I like that. And secondly, how does it handle sour gas?
Right. So getting into the KBOS, we've got a pretty unique sealing system that's like a constant overpressure system that we energize. And we've officially qualified it to 5,000 psi partial pressures on one of our models, and most of the other models can be upgraded to that. So it's quite unique in its sour gas shut-in ability and what it can be exposed to.
I think they was probably referring more to like an embrittlement type thing. Once it's been exposed to H2S for so long, free oxygen sees it, oxidization. And
I got you. Yeah. So that really just boils down to the material trim selection. Use in the metallics, we'll use various types of Inconel, and then depending on how nasty you want to get, you go right up to FFKM on the elastomers, and we're probably the only BOP manufacturer that I'm aware of that can put FFKM as their main sealing element, and that's got to come down to how we do our sealing, which is it's unique.
Okay, so it's a little bit more stronger than, let's say, just a neoprene seal or nitrile seal, or right
from a sour gas perspective. Absolutely.
All right, yeah, neoprene's not gonna work.
I just say it all comes down to the materials, like Billy said, right? So we have test reports that show a FFKM elastomer that we use in our seal design at the highest rating, up to 50% H2S, that is certified to 50% H2S. Right?
Right. So it's pretty nasty. It's a nasty well.
So and it's interesting, right? So it's hard to use that material in a traditional BOP. In our design, because it's a different cross-sectional geometry, it's easy to use that rubber.
All right.
There you go.
All right. So with today's critical operations, right? Primarily for, let's say, snubbing and coil tubing, what are the benefits? Because that's not well control anymore. I wasn't an overbalanced state, or it was in a controlled situation. These guys are working under pressure on purpose. They're not killing this well on purpose. So for that other side of the industry, how does this fit into their concept?
So, in snubbing applications, or where particularly you're going back to that sour H2S gas question, we made a KBOS for that exact application that you're talking about, where it's live. Usually you can use fluids to kill the H2S or circulate it out, and for this particular client, they can't do that, and so that's what KBOS is uniquely suited at dealing with, and having a high reliability. If something were to go wrong, you can rapidly close it in.
All right. Well, you guys have mind if we open this up to questions to the group?
Let's go.
Let's do it.
All right. Let's see what they got, Manny.
So for our first question, what is the largest casing it'll shear?
Well, we did was it 18? I'm trying to remember the exact diameter. 18.
So, yeah, 18.25 inch.
Right.
117 pound per foot. P110 is the biggest
Diameter.
casing that we've actually physically sheared at the 18.75 inch size, I would add. Yeah. So we know we can cut like 10.75 inch 110 pound casing. I mean, it's just, casing is actually the easiest thing for K-BOS to shear.
Right.
So you're not going to stump it.
I was like, so question, force is area times pressure, right? And you're trying to cut a large, don't get me wrong, it's not as thick as a 9.5 inch color, but it's got to take a lot more force to cut that big of a chunk of casing. It's got to take a ton of force to cut that big of a chunk of casing, being that thick. Because there's a more surface area touching it than just that 9.5 inch collar.
Not from the volume of correction, the area of, to your point, the area of material you're cutting, or the weight of it, is less than a drill collar, and quite significantly. Like a drill collar is 214 pounds per foot, right? And that gives you an idea of how much steel's actually there. Without going into it, and there's a little bit more on exactly how it fails. So it's easier to cut a thin walled vessel than it is to do a heavy metal.
Okay, so then that thinner metal than the drill collar, right? How do we stop it from basically getting a burst wound, right? So one of the things that they, like the reason that shear rams got redesigned was to make sure that pipe was centered up. So how did you solve that problem then?
So the way the K-BOS cuts, you sort of think of it around the well. It's like a cigar cutter per se, and so it doesn't matter where it is, and it doesn't matter what it's doing. If it's side loaded, whatever, it will just find it, it'll cut it, and it keeps on going. It's like punching through the drill collar or the casing or tool joint or whatever it's going through.
So it could be leaning up against the side of the wall or dead center, you're gonna get the same effect.
Yeah, right. We side loaded a 6.9 inch was the exact term, slip-proof cross section. UD 165 side loaded like 200,000 pounds, like really jammed it against the wall in condition, like completely constrained axially as we were shearing as well, and it just punched through. We've got that on our website.
All right. Handy Manny has another question from the chat.
I got plenty more. Hasn't been deployed or tested in the Arctic. Does it require heat in order to stay functional in sub-freezing temperatures?
Yeah. So it's similar to a conventional BOP in that regard.
Right. Yeah.
So ambient temperature has an effect on it?
Well, it comes down to the materials, right?
I mean, I fired a gun at -40 and I fired a gun at 110. So
right, from the ballistic action of shearing, no,
that's not
that's not what we're talking about. If you're talking about just the principles of the metal that you're using and its impact toughness and whatnot, then we're just the same.
Yeah.
Right. Like you could make it so there's no technical challenge there. Oh, challenge is probably not the right word. It's technically feasible, but you might want to warm it. That all boils down to what the client's after. For
example, some of the rig ups that we're working with right now, they were looking at running K-BOS on the slope. They were looking at running. We're rigging up next week on some wells in northeast British Columbia, and it is cold. And they clarified they're warming that stack to 50 F anyway, and so K-BOS is on the stack, so that's the temperature that needs to be. So operationally, it wasn't a problem.
What's that in Celsius, Scotty?
The 50F is like 13 Celsius. Maybe.
Celsius, yeah, regulations.
No, like we got a guy on here that can do that math in his head right now.
I got pretty close, no?
Yeah,
Yeah, all right.
pretty good.
Nice.
My wife thinks in centigrade, so I have to be able to go fast.
Nice.
How? What's temperature?
I used to, and now, and then I came to Texas and just threw that out the window.
That's right.
Unimportant
Yeah.
information. Just,
Yeah, just-
there's no room.
4 years of engineering, all that advanced stuff, just dump the metric system. Pounds, here we come.
That's right.
That's right.
We're one of 4 countries in the whole world, right?
Only ones that landed man on the moon.
What's the next one, buddy?
How easy is the control system to rig up on onshore BOPE, and what benefits are there to the end user?
All right. So the control system is independent of your BOP closing unit. And it is the rig up is connecting a pair of cables to the K-BOS and confirming that your control system is available.
Right.
So it is it's a couple hours.
Yeah, pretty straightforward rig up.
Yeah. Yeah. So you making up flanges and two electrical cables.
That's
All
it.
right, so it's basically like I was going to put another set of single gates on just that same amount of time.
I would imagine, less because you don't have to do any of the hydraulic connections or anything like that. So, like we said, 2 electrical connections, site where you want the control systems, and, check everything's working and you're good to go.
All right. What's the next one, Manny?
What's the largest and smallest drift available?
So qualified K-BOSes available that we can deliver in short time are 5 1/8 drift, 13 5/8 drift, and 18 3/4 inch drift. We have designs for a 7-inch one, but we'd have to qualify it.
Right.
Once used, can it be rebuilt on the stack?
Well,
Oh, that's a good question.
That is a good question. So, short answer to that is yes, it could be. Typically what we've done is, you just have the operational urgency. You have the firing bonnet, the next firing bonnet, and the other parts that you just take out the used ones, put the other ones back in, and then we refurb. And then we've done mixes in between. So
yeah, so the unit's been used 3 times on the Invictus,
Right.
and Transocean wanted that thing turned around real quick. The goal was no impact to the critical path of the in-between well maintenance
that's right.
plan. And so we achieved that now 3 times, and we're pretty proud of that.
Nice.
Yeah.
What else you got, Manny?
David Kennedy says, I thought larger rusted casing in poor condition. Shear rams wants to mash or severely deform the tubular instead of shearing it. Is that correct?
That was a much better way of asking it than I did.
Nice. So I don't think that is going to affect shearing from K-BOS. We've seen different material grades make shearing easier,
Right.
but it hasn't become a problem.
So if I understand that question, you're basically saying like a very old used pipe. If I was to postulate on it, I'd say it would just break easier,
Mhm.
and the fish would be clean. How do you say cleaner per se?
Yeah, it'd be
It's
brittle.
It'll be brittle, so
Yeah.
it'll fail really fast.
Yeah.
When you look on our website, when you look at casing, it has a very particular failure mode that it goes through, and I'd imagine it would look a little bit more brittle than that, but essentially of the same form and shape.
And we
So I've had guys in like West Texas storage fields. They use 11 3/4 inch production casing, right? And they said that they always run a backup set of shears because there's really no guarantee that the shears will cut the pipe. It's so ratty and deformed, it just wants to mash it instead of shearing it. But with this kinetic energy, it just instantly cuts it so fast, it's probably not a problem, is it?
Right. That's exactly that's what I would say would happen. It would just punch through it. So it's different. There's no mashing action per se because it's not a split gate valve. You're coming in from one side. It's just a gate valve, and it's shearing from one side to the other. And at that sort of in that sort of geometry, you'd probably just punch through it You'd have 2 bits of pipe and a puck in our K-BOS.
So I guess what I'm trying to, there's really no need for a backup set of shears, is there?
No,
I
They
wouldn't think
always
so.
run two sets of shears.
well, you could definitely consider optimizing that, looking at the K-BOS. I mean, we'd want to get into the details of that project,
Right.
obviously, but I mean,
Yeah, there may
that-
be something regulatory about that, right?
Maybe it depends. Yeah.
Railroad Commission don't really care about anything.
He's up in the Northeast.
Oh, okay.
Okay.
Yeah. So let's talk. I know I'm very confident that running KBOS is always safer than not running KBOS.
Right.
So that's a general answer to a specific question, but I'd love to look at that project. I think we can provide a lot of value there.
Okay, thank you.
I'll send that information over to you in a minute there, Dave.
All right, next question. Do you foresee this being implemented on production wells as well?
Yeah. I mean, intervention work, the first phone call I got when I started working for this company was a large Middle Eastern operator saying, hey, we got a problem working over high sour wells with pressure at the wellhead. And we want to run your tool because it can shear a BHA if it gets stuck across the master valve.
Right.
And so that's a perfect application for K-BOS.
Did I maybe I misunderstood the question. Was he saying as part of the production tree? Like,
I'm not sure. Brandon, would you like to clarify?
come on, Brandon, talk to me, dude.
Yes, I was wondering specifically for that. I don't know about the longevity of it, but it seems as though that would be something that would be nice to have ever present, but especially for, of course, when you bring the stack on or the work over. But yeah, basically ejection of pipes and different things that where we know that we're in the potential to have things getting ejected. So yeah, that covered what I was looking for as far as a visual operation
Right.
and how it could be utilized. But ultimately, if it could be put on a tree is what also my initial thought was.
There's no reason why you can't do that. But K-BOS is you have to think of it like a blind shear ram that you only use in anger, right? So it's not a valve that you can open and close.
Right.
It's like the other driver in your golf bag.
That's right. Yeah. So due to its single use nature, it probably you only want to rig it up when you're working over the well.
All right. What's the next one, Manny?
All right. Have you tested shearing anything that was not steel, like fiber spar, coiled tubing?
Coil. Well, fiber spark. Maybe.
I don't think we have.
No, I don't think so. But I don't foresee any reason why it wouldn't be able to shear it. It's yeah.
All right.
If you can cut it with a really fast moving blade, you can cut it with the K-BOS.
Right.
So not specifically fiber spar, but anything that's not steel. Have y'all tried testing it on the?
Do you mean like I guess stainless steel still? So
And the answer is no.
No.
All right. Thank you.
What else we got?
What else does KPC offer to the industry, and what are you working on? I mean, I'm sorry. Are you working on anything new you can talk about?
One.
Hi, Todd.
No.
So one Reese mentioned, and I think he talked about in great detail in the way that Reese always does. And then there are a couple other things that we're working on, but I don't want to mention them at the moment.
Well, did we just go G4 classified?
No, we covered the control system, right? So
Right.
we have this Stacklight RVM, which is an alternative to a BOP closing unit. Instead of compressed gas to store energy, we store energy in a battery.
Really?
Right? Yeah, and when we first started doing this, me not being experienced in battery energy storage, I just thought about my cell phone. I was like, dude, I have to replace that thing every year. This isn't going to work. And come to find out, well, we built this really great battery borrowing technology from the automotive industry, And the last component on this design that's going to fail is your battery.
Right.
It's 10-year minimum life, right? And this thing is awesome in drilling applications.
I'm going to assume that it's a lithium gel based and you probably got like 36 cells or something in it, right?
Billy knows more about it than me.
That's I'm pulling up a blank if I was just to be honest right this second.
It's lithium
It's
ion.
yeah.
And the cool thing about it is, so let's say you got 80 bottles on your closing unit and your gauge on your manifold is showing 3000 PSI, right? Well, you could show 3000 PSI with one bottle and you have no volume and you go to close your blind shear ram and nothing happens, right? So you have to go do your pre-charge checks and there's procedures in place to make sure that doesn't happen, right? Well, with energy storage in a battery, it's constantly monitoring it. So if you have a little green light that says I'm good, and a red light bad, so you just don't use that one, and you know how much charge you have, you know how much voltage you have. So it is a fundamentally more reliable system because it tells you if it's not there.
So you guys have a couple more pictures that we haven't shown yet. Is there one that you want to show where we can look at that access port that you were talking about in case, we do have to shut in and get underneath it or read pressures?
I'm trying to think of any of the photos we got there.
You're talking about a side outlet?
Yeah.
Pull up the 1310 K-BOS picture.
That's the big one, right?
No,
Oh.
it's the white one. Yeah, you can see it's just a standard 2 1/16 API studded ring groove side outlet, fully rated 10K. So when you're thinking of BOP side outlet, that's what K-BOS has. No different.
And so then same outlet, or not same outlet, but same flanges, same rings.
Yep, standard ring grooves. That's
Yep.
the API 6A,
Okay.
6X.
So you're not having to get any extra or specialized equipment or have something delivered out in the middle of the night from, somewhere in the other side of the world. And
Flange connections, top, bottom, and side are all standard, industry standard.
nice.
Yes, sir.
We have one more question real quick.
Oh,
It's a
okay,
real
okay.
quick question.
All right.
Where is it manufactured?
Everything's made in the USA.
Proudly made in the US of A.
Would you like me to sing God Bless America?
We would actually.
Can we follow it with God Bless Texas?
Yes.
Right.
Yeah, we can. As part of America.
All right. So you want to talk some more about the RVM you said?
Yeah, I'll pitch it all day. It's a really exciting improvement.
Okay.
Right.
Let's talk about it real quick.
Yeah. So let's think about rigging up. Let's think about a rig move. Okay. If you are moving a BOP from one location to another, and your closing unit needs to move from one location to another, you have all these suitcases you have to move. You have to work at heights to connect everything onto that BOP, right? And you have to put this big heavy closing unit on a trailer. Maybe it's 2. All right, so you're looking at 2, 3, 4 truckloads.
Okay.
Right. So RVM.
Yeah. Unless you're skidding a rig, but yeah, if you're going down the road, yeah.
So it could be built in the superstructure of the rig and you solve that problem, right? But that's just one way to do it if you're on a pad. So the RVM, what the Stacklight RVM system does is we put part of the BOP control mounted on the BOP, so it's permanently there. And then we have the energy storage, which fits, is about the size of a refrigerator, like I told you. And so that you can put that anywhere you want, right?
What's the benefit of having it on the BOP?
Well, so when you rig up, it's just 2 connections. It's supply and return with an electrical connection to tell that valve manifold what to do, right? So what you're doing is you are saying, I want to close, for example, a blind shear ram. Or let's do something more interesting. Let's say I want to close a annular and I want to strip in, right? So you say I want 1000 PSI on my annular, right? So you tell the pressure, it sends 1000 PSI to that annular, and it also charges the bottles on our little control system. So as you're stripping in, it's maintaining 1000 PSI in that annular because you told it to, and it's doing all of that with 2 hoses connected to your BOP.
Okay. And then I can make that adjustment anytime I want to.
Yep.
So
Right.
if I start leaking a little bit because of degradation due to tool joints or just wear and tear from stripping, right?
Yeah, you just dial up a little bit on the HMI and keep on going.
And I don't have to go to the accumulator to do that. I can do
That's
it on
right.
the floor.
So let's go back to talking about shearing. because this is you know, the last thing that goes wrong before a blowout, and we want to stop blowouts, right? So when you need to shear, you do your closed blind shear ram, and in some systems, then you have to push high pressure override or high pressure bypass, so you get your shear pressure, right? And on an accumulator system, you start at 3,000 psi, and as you draw down your volume, you might finish at 2,000 psi or 2,300. What if it takes 2,500 psi to get through that pipe and you don't?
Because you're not putting it to every single ram, you're just putting it to the one.
Yeah. What if you're what if you're fighting a well and you've used your closing unit to close pipe rams and annulars, and you don't have volume, and you push, okay, I lose, let's close the blind shear ram, and you don't have the volume to do it, and you don't hit your final shear pressure and it doesn't cut.
Yeah, well, you're only as good as your last test, right?
That's right. So that is a limitation of traditional hydraulic closing units. The Stacklight RVM has full function pressure available at all times. So because of the way it works, when you close it and you say, I want 3,000 psi final closing pressure, you can have that at any time. And because we have so much more energy storage in the batteries, it's equivalent to about 300 accumulator bottles, right? So you have a lot more in a very compact space.
I may have underestimated your sellage. I don't even know that's a word, but it is now.
Well, I'm just talking about what it's designed and what it's compared to. So you want me to stop selling?
No,
You did you said, yeah, Reese, go for it. This is why Reese, he goes for it.
I'm interested. So
Jumping right after it. Yeah.
300 bottles is a lot.
It's a
I
lot.
don't care if it's 5-gallon bottle, 10-gallon bottle, 20. That's a lot of bottles.
315 gallon bottles at 3,000 psi. Yeah. So that's
Right,
what I'm comparing it to.
And it's bringing on, new technologies. Batteries have come a long way. You think about like 20 years ago, what a battery technology was at versus the energy density they can achieve now. So, it's just significantly greater energy density and a smaller footprint that you can also monitor very easily as well.
Yeah.
Right.
And let's talk about a drawdown test.
Well, I got one question.
Oh, yeah,
real
go
quick. So you got a battery, but let's say you're in the Mediterranean where the seafloor is like 4 degrees or something ridiculous, right? I know living in Wyoming that batteries don't like cold temperatures. So how is this mitigated? How did you solve that problem?
So the system I'm talking about is designed for being on surface, right? And you do need to control the temperature. But it's the same as your existing BOP equipment.
All right. And is there a temperature that it can't exceed? So like my golf cart batteries get a little too hot, they start swelling and leaking and doing bad things. So there's got to be a limitation to it. And we don't just work in really, really cold environments. Like I've also worked in the Middle East too, right?
You're right. There are limits. At what's the upper range at 140F?
Yeah, right. And then this also comes down to battery sizing on your closing functions, etc., to make sure you're not drawing it down too fast or hard as well. So some of it's more of an engineering challenge per se, which we've worked on and now you figured out. So
yeah,
right.
Yeah, it's going to do just fine anywhere you're using it,
right,
in the intended way, in terms of temperature.
All right. So please continue. I'm sorry. I totally cut you off, bro.
No, it's fine.
These are good questions.
They're great questions. So let's just talking about capability and how much fun this is and why this is. Why do we have to do something different? Why should we do something different? Well, so let's talk about drawdown test. So you do a drawdown test to find out if your closing unit is fit for purpose.
Yeah.
Right.
Or because they make me, but yeah.
Yeah. Right. So this system can just apples to apples, can do 3 or 4, maybe 5 drawdown tests, let's say 3, and with full closing pressure at the end of the 3rd without recharging.
That's cool.
Right.
Right.
So that's when we're talking about, we're not at the limit. We're trying to deliver equipment that can achieve its operational goals in keeping us safe without having to be at the ragged edge of what it's designed to do.
All right. One of the things that a lot of people don't realize is that even if you have an HMI panel and a 20 pin coming out of the bottom leading down to that accumulator, it's still on most rigs. There are some rigs with nitrogen systems dedicated just to move your handles, your valves back and forth, right? but most rigs, I'm saying about 90% of them in the industry, it's still air that moves that back and forth, whether it's an old school panel with a master valve or an
Mhm.
acknowledge button, an HMI panel. Do I still have to have air to run this?
Not on the RBM, no. So all the valving is electrically controlled as well, and electromechanical turning of the valves using gears.
So
And then it fully encapsulated, gearing system, and that's why it's able to. Some of it's mounted directly onto the BOP.
so you're
well.
cutting the middleman out, right?
Right.
Basically, so that 20 pin really does go, and that electronic signal says you do this.
That's right. It's an electronic control system.
Nice.
That's right. And that doesn't mean we can't receive an air signal and do a 0 to 20 milliamp converter and all that like normal.
Mhm.
But that's not required. That's not part of the system. The system is direct digital control of everything.
Beautiful.
Yep.
Said you got something else, Manny? Oh, I thought I saw you flip the flag.
No, we haven't flipped the flag.
All right.
Yeah. So that's the way we're looking at this. We're trying to, and we really want to be a regular part of the dialogue. Right. And the way kinetic pressure control looks at the industry is we want to ask a different question. We don't want to ask, how do I make a better closing unit? We don't want to ask, how do I make a better BOP? We want to say, how can I use the best technology available to stop a blowout? And if that results in something that we can do better than somebody else, we're going to invest in that product and deliver it to the market and teach you how to use it.
All right. Now, you have said that a couple of times, is trained how to use it.
Mhm.
So are you providing training for the guys to how to operate this, how to reset it, how to make sure that it's testing properly? Or, I mean, is there some things that a tech has to come out for?
That's right.
That's right. Yeah. It all depends. Like for just the day-to-day operations, we do, with every package that we've done, we've trained the crews, whether it's KBOS or RVM, we train people, and we train the trainer as well, right? Like some of the organizations, they want to go a little bit deeper into the technology, and we do that as well. Obviously, if there's going to be certain maintenance activities that Kinetic should do, and then that's not dissimilar to any other manufacturing and technology company.
All right.
Another thing that we do in our approach is one of the best ways to prevent a tool from being improperly used is make it easy to use.
That's right.
Right. So if it's easy to use,
You know what a crescent wrench is, right?
yes.
Okay. I'm just saying. But sorry, go ahead.
Well, no, and that's a good point, right? I couldn't get this connection on, so I got a wrench to it. Right. That's how we solve problems. A lot of problems. Right.
Or I
Well-
couldn't get this connection off and I hit it with a wrench.
That's right. Yeah. So in this case, that's the wrong answer. Right. And so we need to train people. If it's hard to do, you need to stop. It should be easy. You should be clicking this in with your hands and it's done. And so there's definitely, when you do a risk assessment of using KBOS or RVM, some of the highest risks identified are untrained personnel inadvertently causing problems. So we really have to make sure that we're properly training people.
All right. And have you seen, because we're promoting people really fast now. Like, and I'm scared to say that it's a lack of options, but we're starting to get back into full swing, and we're promoting people quicker than normal at the moment. So have you seen that affecting how people are operating or learning or using our equipment?
Well, everyone knows that turning people over and keeping trained staff on work site is one of the biggest challenges faced by the industry today. That's a fact. And so I'm not going to say that, you have to have trained people to operate this equipment. So we're not getting away from that. But this equipment is the same or easier to learn than the existing kit.
All right. And
I think that answers that question, right?
yeah,
Okay.
yeah. This guy might be drilling for 6 months. He might be pushing next month, and now somebody else has got to take his place, right? So now I got to bring another guy in.
Yeah.
So how do you maintain, or do we rely, like it's been for years, where, okay, these guys learned it and now they're going to teach these guys who are going to teach these guys?
If we're in a scenario where we're going to follow a procedure, then the procedure is sufficient and no training is required.
Perfect.
right?
Right.
If we're not following a procedure, then you do need to train someone. This is how you know if it's available. This is how you know if it's not available.
Mhm.
If you need to use it, you open this lever, you push here, you push there. You do not do that unless the tool pusher tells you to.
All right.
Right.
And is there any specific circumstances that where it would require a technician to come out? Right.
If it's broken.
Yeah, if it's broken, basically.
Yeah.
Yeah.
And it'll tell you if it's broken.
That's
That's right.
exactly right. That's the best thing about the K-BOS. It's monitoring itself all the time, and I'll tell you, boom, I'm broken.
Wish
Yeah.
a couple of girls in high school would have told me.
But let me tell you, the K-BOS in particular has no planned maintenance in 5 years.
Really?
Yeah.
So you get to do your Cat 3s and get new COCs.
That's right.
Beautiful. Said we got another question from the chat.
Yes, we have a couple actually. So, firstly, are there any issues cutting multiple internal strings?
Short answer is no. I think if you go onto our website again, we've got a 16-inch casing with a 6 5/8" drill pipe in the middle of it, and on that same one we put slick line and wire line, on it as well. So multiple casings is not an issue.
All right. And secondly, can you give us a cost comparison between other current tech?
Yeah. So as a rental tool and apples to apples against new capital equipment, it's comparable.
Yeah, that's
Right.
probably the simplest answer way of putting it.
Yeah, I think that's right. But if you're comparing it to maintaining an existing piece of kit, you're comparing, fixing your old car to buying a new car. So,
Or just the cost of the repercussions.
yeah. We're providing a lot of value here, but you're looking at new kit. So those are just the facts.
Right on. Well, we got last call.
I've got a question real quick.
I knew it. I knew it.
I knew I couldn't keep my mouth shut, guys. I know. Hey, I may have missed it. Can this be field rebuilt? Or does it have to come back and be rebuilt back in the shop? So,
You really don't want to do it in the field because of the philosophy, right? This is a blind shear ram that you only use in anger. So if you're using something in anger, well, it has just done a really big job for you. Right. And so you want to go back and refurbish that. You want new parts. You want it all in spec so that the next time you need to use it in anger, it's ready. So if you have that philosophy, then you wouldn't want to fix it in the field. You'd want to take it back and make sure that it's like new specification before it goes back out to work.
And you said that a couple of times now, and I thought about it the first couple of times, and I was like, I really like that, because if you do something out of fear, if you're scared of her, she's already won, right? It out of anger means I'm gonna solve this problem.
That's right.
I like the way that's worded. I do. Anything else, Manny?
I don't know. Ask the chat. Anybody in the chat want to speak up and speak their mind? Ask a question. Now's the time.
You can pick on Manny for being a Cowboys fan.
Or you can pick on Tony for being a 49ers fan.
so when you guys look at it, well, and you're looking at, let's look at this 3 to 5 years down. We know how regulations are changing. We're looking at this. Do you see the potential for K-BOS or like products as being that answer for, the governments and saying, hey, this is going to be a mandatory, device that we're going to put on possibly storage wells or, any of those high volume, high pressure situations. Is that what you're looking to push this tech towards?
So that may well be the result in the future, but I don't think that's how it's going to come about. These companies that are delivering and executing these projects, I think they truly care. Like when we're working with ConocoPhillips or ExxonMobil or Shell or Chevron or Total, Total Energies, you name any of these guys, that they truly care. And I think they're going to say, we want this so that I can say my operations are fail safe. And that's going to lead. And then, they're going to be leading the way, saying this is the right way to do it. And that's how it's going to happen.
All right. So thank you guys very much for being here. Is there any closing statements that you'd like to make?
No, I just thank you for your time and for people listening to the technology that we're bringing to industry, and we hope it adds value to your operations.
If people have more questions or inquiries or just want to know, how would they get a hold of you? Where would they find you at?
Oh, yeah, you can contact me directly, Reese Jones. It's reese@shearanything.com. My phone number is 713-213-7993. I'm on LinkedIn and I'm on the website.
All right.
It's pretty smooth. Same thing except Billy at shearingthing.com.
All right. Just Billy?
Yeah, just
All
for
right.
that.
Make it easy.
That's
Well,
right.
thank you guys for your time. I appreciate you. I really, really like what you guys have built, and I think it's going to be it's going to change the industry.
Looking forward to it.
Thank you guys very much. Thanks for joining us today, and we'll see you next time.
Yeah.
Thank you.
Thanks a lot.
We would like to thank you for watching. I'd love to give a special thanks to Manny, the producer, and Scotty, the director, for all the hard work they put in. Nobody gets to see. Please like, subscribe, and share. Thank you once again, and we'll see you next time.